Flash flooding for Nebraska, Kansas, Oklahoma, Texas, and New Mexico, and we may see an isolated severe weather risk for the Texas Panhandle. Good morning, I'm meteorologist Pew. Today is August 30th, 2025. Briefly talking about the severe weather, we have a marginal risk, or 1 out of 5 in the Texas Panhandle, and what this entails is we only have a 5% chance to see both a wind and hail event. But the main concern today is flash flooding, as the Weather Prediction Center has issued again a slight risk, or a 2 out of 4 for both the plains and the southern plains, and this is going to persist into tomorrow as well. Some places are already seeing convection from remnants of last night's storms, but unfortunately this is going to continue for places like eastern Nebraska, central to eastern Kansas, and northern Oklahoma, where we're going to see a lot of these storms pop up early afternoon into evening, and then eventually even into the night. And for places like western South Dakota, you guys are going to see constant showers as well. And so for rainfall totals, we're going to see isolated places could get up to 4 inches or greater. For the Texas Panhandle area and also for western Texas, you guys may see isolated cells around 22Z, or that's 5 p.m. Central Time. And a lot of these isolated storms may turn into clusters and then travel eastward or southeastward, and we may see rainfall totals up to 1 to 3 inches. Though multiple recent models are suggesting that some of these clusters may form an MCS, or Mexico-convective system, or one big blob that's going to form in eastern Texas. And if this does hold true, some models are suggesting that rainfall totals could be up to 6 inches or greater. And also, if this were to be true, this would happen during the night as well. Okay, so why this is all happening, if we look at 500 millibars of midway through the troposphere, that ridge that we've been seeing in the southwest is finally starting to dissipate and weaken. But with that, we do have a shortwave trough that's going from the plains all the way to the Texas Panhandle, and we talk about shortwave troughs a lot in this page. And with shortwave troughs are generally associated with decent shear, which is going to tilt those updrafts and prolong the storms. And we can see that we have some, but another thing that shortwave troughs are associated with is vorticity, or spin, which is going to help upward motion. And this is due to the curvature of the height contours. But if we look at the plains, we can specifically see the wind bars spinning cyclonically or counterclockwise. And as we know with low pressures, they spin counterclockwise. And as we know with low pressures, they're associated with upward motion. And so even if we look at reflectivity, we can see that the storm motion also spins cyclonically. So we know that there is a low pressure centered around here. And then looking at the surface map, we can also see this depicted here as well. And we can see this low pressure is associated with the cold front. And we can see this being reinforced if we look at satellite imagery by the clouds and the constant convection that we've been seeing. The cloud cover is preventing some sunlight, so it's preventing some surface heating, but also with the precipitation, it's cooling this area. So in these areas, we're going to have a lot cooler air than the surrounding areas. And going back to the surface, we do have a high pressure in the Great Lakes, and it's very, very broad, and high pressures are clockwise flow. And it's so broad that we're actually having a lot of heat and moisture being transported from the Atlantic all the way to the Mississippi Valley, all the way north to the plains. And we can see that these areas have clear skies, which is going to have more sun, more surface heating, and more instability. But for the Texas Panhandle, we're going to have 2 low pressures that's going to help transport that warm, moist air into that area. And that's why we have